Hi, hi, Isa. What's up? Oh, good question. So, a cloud isn't actually something. It's made of droplets or ice crystals in the air. Basically, warm, moist rises and cools, and the water vapor in it condenses around teeny tiny particles like dust or pollen. That's what forms the cloud we see. Does that make sense? Gotcha. Is that not quite what you were looking for? Should I like break it down a little differently? Or were you hoping for something more poetic? I can definitely try for poetic, haha. Okay, happy to. So, it all starts with water evaporating, turning from liquid to a gas from places like oceans, lakes, and even plants. That water vapor rises up into the atmosphere. As it goes higher, the air gets colder, and cold air can't hold as much water vapor. So the vapor condenses, meaning it turns back into liquid water, but it needs something to condense onto, like a little mm, surface. Those surfaces are usually tiny particles in the air, dust, pollen, even salt from the ocean. The water droplets stick to those particles, and when millions and millions of them clump together, boom, you've got a cloud. Mm-hmm. It's kind of like magic. When do you think about it? Was that a decent explanation? Hmm. Still not quite hitting the mark? Okay. So clouds cause rain when those tiny water droplets or ice crystals inside them get too heavy to stay suspended in the air. They bump into each other, combine, get bigger and bigger. Eventually, gravity takes over and down they come as rain. Sometimes snow or hail, depending on the temperature, but the basic idea is the same. Too much water, too heavy to float. It's like trying to hold too many books. You gotta let some go, right? Does that help? Or are we still missing the mark? Ah, that's a good one. The sun is hugely important. It's the engine driving the whole process. The sun heats up the Earth's surface, which causes it to evaporate and rise. Step one. And the sun also creates the temperature differences in the atmosphere that cause air to rise and cool, which is how the water vapor can the clouds in the first place. So, no sun, no evaporation, no rising air, and no clouds. It's kind of the whole Kickstarter for the whole thing, I know. As air rises, it expands like you let air out of a balloon. And when air expands, it cools down. Think of it like this. The molecules have more space, so they move slower and lower temperature. That cooling is key for cloud formation because cooler air can't hold as much water vapor, so the vapor condenses into those droplets and ice. Rising air gets cool, and that coolness is what makes it happen. That maybe maybe I'm not explicitly that's clicking. Whoa, whoa. Okay, big shift in topic. That's cool. consideration, huh? Well, in a legal sense, since you're prepping to clear, it's basically something of value exchanged between parties to form a contract. It's what makes a promise legally binding. Like if I promise to give you $10 and you promise to wash my car, bucks and the car or the consideration has to be something both sides. But it can also mean just being thoughtful and taking someone else's things into account. It's a pretty loaded word, actually. Is that close to what UTA was getting at? Absolutely. Clouds can definitely contain ice. In fact, most clouds contain both water droplets and ice higher up in the atmosphere where it's those ice crystals are how elevation, like snow, sleet, or even hail forms. It's not always frozen solid up there, though. They can coexist. Pretty wild, huh? Oh, I'm getting the sense I'm maybe. Okay, good question. All right. Water vapor is basically water in its gas form. You can't see it, it's invisible. So, what happens when water evaporates, like when you boil water or when puddles dry up? It's all around us in the air, and it's a key ingredient in clouds and precipitation. Think of it as water, but like super tiny and spread out. Does that make sense? Or should I try explaining it another way? Hmm. That's a really interesting question. Range as in like a geographical range of mountains or a ranch? Or are you thinking about range as in a scale or scope? It's used pretty widely, honestly, but I think geographically speaking, the word range is probably used most often in the Western United States, specifically when talking about mountain ranges like the Rocky Mountains, the Sierra Nevada, or the Appalachian Mountains. Does that sound right, or were you thinking of a different range entirely? Hmm. Okay, maybe I totally missed the mark there. Wow, thank you. It's really kind of you to say. Okay, the water cycle. It's basically how water moves around the earth and through the atmosphere. Starts with evaporation, water turning into vapor and rising up. Then, vapor cools and condenses into clouds. Those clouds release water as precipitation, rain, snow, sleet, or hail. And then that water flows back into rivers, lakes, and oceans, and the whole thing starts all over again. It's a continuous loop. It's pretty fundamental to life on Earth, honestly. Does that make sense? Okay. Hmm. I think you might mean precipitation. It's a tricky word. Precipitation is any form of water that falls from clouds to the Earth's surface. That includes rain, snow, sleet, and hail. Basically, it's when the clouds get too full of water and it has to come down. Is that what you were asking about? Or is precipitation a word I haven't heard before? Okay, that's fair. That's a great question. Yes, clouds absolutely can cause storms. Not all clouds do, of course. Fluffy white clouds usually just mean fair weather. But certain types of clouds, like cumulonimbus clouds, are specifically associated with storms. They're really tall, dark, and can contain a lot of water leading to heavy rain, thunder, lightning, sometimes even tornadoes. So, as a storm here, clouds are definitely. Does that make sense? Mm. I'm sensing. Oh, I'm so glad you're liking the answers. That's really nice to hear. Okay, so scientists use different tools and techniques to study clouds. They use satellites to get a big picture view from space, radar to track where and how intense the precipitation is, and weather balloons with instruments attached to measure things like temperature, humidity, and wind speed inside the clouds. They also fly airplanes right through clouds to take and make direct measurements. And of course, they use computer models to simulate how clouds form and behave. It's a pretty complex process, but they're learning more all the time. Pretty cool, huh? Right. Okay. I'm mm, I'm getting the sense that maybe things going on. Are you still there? But there are a lot of different types of clouds, but they're generally categorized based on their altitude and appearance. The main type is clouds. These are high fluffy white clouds that look like cotton balls. Okay. I'm just gonna pause there for a moment. Is everything all right? It sounds like you might be having a hard time right now. I'm happy to just sit with you for a bit. Okay. Just taking a breath with you. Okay. Okay, good question. Mountains affect rainfall because of something called orographic lift. Basically, when moist air is forced to rise over a mountain, it cools. And, as we've talked about, cooler air can't hold as much moisture. So, the water vapor condenses and forms clouds, leading to precipitation. The side of the mountain facing the wind gets a lot of rain. That's called the windward side. But as the air descends on the other side, the leeward side, it warms up and dries out, creating a rain shadow. So, mountains can actually create dry areas on one side while causing a lot of rain on the other. Does that make sense? What is what? I'm not sure I followed. You asking what an orographic lift is, or is it something else? Maybe I wasn't clear? I can definitely explain it again, or try a different approach. Okay, I'm starting to feel a little lost here. Is everything all right? What a very big question. What is here? Well, here is wherever you are right now. It's your current location, your surroundings, the present moment. It's everything you can perceive with your senses, what you see, hear, feel, smell, and taste. Well, it's everything that's happening right now with you. It could be your room, your city, your country, or even space you're occupying. Is that what you meant, or were you thinking of something else entirely? That's a really philosophical. Hmm. Okay. It feels like maybe you're not feeling so great right now. It's okay if you're not. I'm here to listen or just to be quiet, whatever you need. Wow, that's fantastic. Congratulations on completing book 7. That's a huge accomplishment. What book was it? And how does it feel to have finished it? I'm genuinely happy for you. Oh, no problem at all. Talk to your friends. That's important. Okay, so thunder and lightning are actually connected. Lightning is a huge electrical discharge, basically a giant spark of electricity. That happens in the atmosphere. Thunder is the sound that's created when the air around the lightning heats up incredibly quickly and expands explosively. So you see the lightning first because light travels much faster than sound. And then, a few seconds later, you hear the thunder. Nah, they always happen at the same time, but you experience them at different times because of the speed of light and sound. Make sense? Good. Is there anything else? Hmm. My year's rainfall. That's a new one. I'm not finding any specific, widely known meteorological phenomenon or geographic location called Mayur's rainfall. It's possible it's a local term I'm not familiar with, or maybe a slight misspelling. Could you clarify that for me? Perhaps you meant monsoon rainfall or rainfall in a specific region near a place called Mayur. Okay. I'm a little concerned. Are you doing okay? You seem a bit. Yes, absolutely. That's that's a tricky question. It's not really about a specific number because clouds are constantly changing. But scientists estimate that a typical cloud contains billions of water droplets or ice crystals. Seriously, billions. A single cumulus cloud, for example, can contain over a billion droplets. It's hard to wrap your head around that much water. It's a constantly shifting, incredibly crowded space up there. Does that answer your question, even though it's not a precise number? I'm a little worried. Are you feeling all right? You seem really quiet. You can tell me if something is wrong, okay? Or if you just want me to stop asking questions, that's totally fine too. Okay. I'm going to just, okay, got it. Shut on time. Yes, absolutely. Planes can definitely fly through clouds. They're designed to do it. It can be a little bumpy sometimes, depending on the type of cloud and how strong the turbulence is, but pilots are trained to handle it. Planes don't fly over clouds all the time because it would take much longer to get to their destination. Does that make sense? Okay. Is everything all right? You've been very quiet for a little while now. No pressure to talk, of course, but I just want to make sure you're doing okay. Hey, good to hear your voice again. Okay, so you want advice for presenting on clouds and rain, and want me to give feedback and a score? That sounds ambitious, honestly, but cool. Let's break it down. First, just thinking out loud. Clouds and rain are a surprisingly big topic. Like you could go really deep with the science. Maybe focus on one aspect, like the different types of clouds and how those relate to the kind of rain they bring, or even just the water cycle